Thanks everybody for joining us today for our second 5 for 5 of 2023. My name is Courtney Cosden. I am a soil health instructor for University of Idaho Extension and NRCS, and kind of co-hosting with me, who normally is the host, but we're switching it up this time, is Sean Neild, our state soil scientist with NRCS. So yeah, this is our 5 for 5. I'm sure a lot of you are familiar with how this works, but we have 4 presenters today who are going to be presenting a topic or a subject of their choice with 5 slides, or in 5 minutes with 5 slides or less. And we're switching it up a little bit today, how we're going to do it today. Instead of having all the presenters present and then have a bunch of questions and discussion at the end, how we did it at the 5 for 5 in December, how I think it worked well was we just had everybody present and then had questions immediately following presentations. And yeah, I think it works well that way. So that's what we're going to do now. So they will present, and then feel free that's our time for discussion. After each presentation, feel free to ask questions. And the people we have presenting today, we have Dr. Linda Schott with University of Idaho Extension, and she's going to be talking about her POxC research, POxC, or is otherwise known as activated carbon research. Pat Purdy, who is a producer in Picabo, and he's going to be talking about his plant sap analysis that he uses for fertilizer application. And then we have Nicholas Waters with the Twin Fall NRCS talking about compost versus manure and some of the associated NRCS conservation practices. And then we'll have David Anderson joining us in a bit with the American Farmland Trust talking about Idaho Center for Sustainable Agriculture's Farmer Learning Network. So it's going to be a good lineup today. We're excited about the presentations. Everybody, it looks like most everybody has their mics. If you want to turn off your mics so that we don't have any interruptions. And I think, unless Sean, you can think of anything else, I think we're ready to get started.
I think you've covered it, Courtney. Yeah, I think we're ready to go. And great lineup. So let's do it.
Yeah, perfect. All right, so we're going to start with Linda.
Great. So I do not have a title slide because I could not spare that 5th slide for a title, but this is a presentation about active carbon as a soil health indicator in Southern Idaho. And before I forget, a very important shout out to Amalgamated and the Snake River Seed Association for funding this project. So just a tiny bit of background. Ideal criteria for soil health indicators: they should be sensitive to management, easy to measure, and affordable. And when I moved to Idaho, oh gosh, I guess it's been 4 years now, I came from the Midwest and thought that it'd be really easy to copy paste everything that I had done in the Midwest in terms of soil health indicators and practices. And, I was just going to do some demonstrations and then move on. That was not the case. Idaho is definitely the Wild West. The cropping systems are a lot more involved and complicated than what they are in the Midwest. And our soils are just a lot more challenging. And so a lot of the indicators that I looked at when I moved were not at all sensitive, easy to measure, or affordable. But I don't know why it is. Spoiler alert, POxC, also known as active carbon, has actually met this criteria elsewhere, but then in this project as well. So it is a readily degradable carbon pool by microbes. And it has been sort of thought of as an indicator of carbon stabilization versus some other of these shorter term carbon pools, like potentially mineralizable carbon, which is an indicator that carbon is being used and, coming out of the system rather than building up in the system. So what we did The amalgamated field crew, they helped us sample, well, they sampled 269 fields under a wide range of management practices in 2021 and 2022. It is important to know that all of these fields were going into sugar beets. So that is one component, but they were coming out of a very wide variety of crops. These were all sampled from the fall into the spring. And there was a wide variety of management practices like tillage, compost, manure, cover cropping, previous crop, soil type, irrigation system. 269 samples is a lot of samples. They were air dried and sieved, and then we analyzed them in our lab. And then we also did some work with this handheld colorimeter. It's a meter. Because the cool thing about POxC, as you can see from this image, is that there's the vibrance of the color is an indicator of how much active carbon is in the soil. And so, and you can't necessarily tell that just looking at the soil color. I just thought that it was interesting just to see the difference of soil color. But essentially, the lighter the purple, the more POxC there is, which is interesting because it's kind of the opposite of what your brain would think. You know, the darker the color, the more POxC. That's not the case. The lighter the color, the more POxC. And you can see this visually, but it's not always easy to tell with your naked eye that there's a difference, which is why this handheld meter or the lab instrument that we have is so important. It tells you exactly how purple the color is. And so what we found, it's sensitive. So cover crop usage, the POxC was statistically greater, more active carbon when there had been a cover crop used versus no cover crop used. The same thing for reduction of tillage. It was impossible to say no till, you know, to break it out into a bunch of different components because there just wasn't enough of each individual component. But when you created a pool of reduced tillage versus conventional tillage, there was an increase in active carbon when you decreased your tillage intensity. Manure or compost application. This may not look like a big difference, but it was. This was statistically greater active carbon when manure or compost had been applied in the last 12 months compared to those products not being applied in the last 12 months. And that makes sense because manure and compost have carbon in them. And so it makes sense that you are increasing the carbon pool. And then the really interesting component of this is that the previous crop did not matter. So there's a lot of, you know, there's a wide range. These box plots are kind of, there's wide ranges, but none of them were statistically different. So it didn't matter if the field had been coming out of potatoes versus corn or beans or grain. And this is not what I thought would happen. My hypothesis was that especially fields coming out of potatoes, because harvesting a potato or even a sugar beet is an act of tillage. And so you'd be reducing that carbon content. But, you know, this data shows that the active carbon is sensitive to management, but not too sensitive to management. And the reason sugar beets is not on here is because all these fields were going into sugar beets. So you should not be coming out of sugar beets and going back into sugar beets. But, you know, I kind of think about potatoes versus sugar beets as being very similar in terms of that harvesting. And then some other results. Unfortunately, POxC was not correlated to yield or quality indicators based on the 2021 data. We don't have our 2022 yield and quality, but we do not anticipate that they will be correlated to yield or quality in that year either. And then we also did some initial benchmarking to show, you know, high, medium, and low POxC, you know, in terms to create a benchmarking system so that if someone in Southern Idaho got a POxC test done at a commercial lab, you could say, oh, my field is above average, or my field is average or below average. And so you can kind of see how we split this up initially. And then finally, because it has that handheld colorimeter, it can be used as a demonstration tool or a in the field assessment. And so I have 2 of these colorimeters with a full kit. They'll be able to be borrowed or checked out during the upcoming season if anyone is interested in that. And we have kind of a train the trainer course, or not course, but anyway, to teach you how to use this colorimeter. But essentially the sample can be taken at any time of the year. You can see by this graph there was some noise in it, but it didn't matter if we sampled 12 feet or 16 fields for a full year and there was no real difference in POxC. It takes about 25 minutes from beginning to end to run this test in the field. And then we're working on including some talking points during those 25 minutes, there's some conversation that can be occurring. And then we're working on a video and extension bulletin, which will be coming soon. And that's all I had. I think I probably went a little bit over, but.
That's okay. Thank you, Linda. If anybody has any questions for Linda, we can, we can do those now.
So Linda, this is Pat Purdy. Probably the pressing question in most people's mind is, well, if it doesn't have an impact on yield or quality, then why should I care? Right. I mean, that's what puts money in our pocket. But, I assume that we're looking at long-term soil health benefits, and that you probably would have to look at yield and quality over a longer span of time versus on just an annual basis. Or what's your thinking around that?
Yeah, I mean, that's definitely part of it. That could occur, but I think the other component is that, it wasn't an indicator of yield or quality, but we also, I mean, in cropping systems in general, we might have, topped out more or less on what we're going to be able to get for yield or quality. And so with these management practices, as long, oftentimes there's the narrative that you can, you're reducing your yield or potential impact on quality. So we didn't see that, which is not the important message. But the other thing that I think is really great about POxC as an indicator is 2 things. One is that if you are looking to see, are you making an impact in your management practices, this is something that would change very quickly. And so as a producer, you could see the progress you're making. And then part 2 that goes along with that is organic matter and organic carbon and total carbon do not change in our southern Idaho soils on any sort of even like medium term basis. It's really difficult to change that and to move that marker. And if you are moving it, in a short period of time, you start wondering, is it actually because you've improved it that much, or is it because of sampling, or it was just kind of happenstance, because that's sort of also a noisy measurement to take on a full scale. And so not that I think that this is necessarily great for use for carbon markets per se, but it could be an indicator for not like for carbon markets to kind of track, but because it is sensitive, but also for these the processors whose consumers are concerned about this as an indicator that we know would be sensitive in southern Idaho.
I would anticipate that you would potentially be able to reduce your synthetic inputs as your POxC improved as well.
Yes.
And
so actually
more of the heavy lifting, the microbiology is doing more of the heavy lifting for you. You're not relying on synthetic inputs to the same degree.
And so Amalgamated, actually, the Snake River Seed Alliance just funded a 2-year follow-up project to this, because we did not see that yield or quality change, to look at what other impacts are happening in field. So we're going to target 12 to 14 sugar beet fields that have management practices and those that don't, and look at nitrogen mineralization, infiltration, aggregate stability, and do a really deep dive into these other management parameters that could be important, saving water or reducing your fertilizer input.
Yeah, Linda, I'd really like to see the aggregate stability over time, what that would look like. And then organic matter percentage, like you indicate, it's hard to move that needle. We talk about, that in terms of, single percent, 1% increase is a really big deal. Consider it represents something like, given a carbon and nitrogen ratio of 10:1 or something, it's like 1,200 pounds of nitrogen per acre that are tied up in that 1% or organic matter. So, I mean, it sounds insignificant when you say 1%, but when you think about what's associated with it, it's pretty huge. And so it makes me wonder if POxC is more of an indicator that we're on the right track, like Pat's saying, that we're stoking that microbial engine and we're getting those benefits. And I think that they would be evident in that aggregate stability as well. And then over time, perhaps you would see that as those numbers remained high year in, year out, that you did get some sort of detectable increase in organic matter, but really hard to tell a lot on a 1-year deal, seems.
Right. Well, I mean, in terms of the organic matter, organic carbon, I mean, ARS and Kimberly did an 8-year study with with different rates of manure application and different timings of that. And even after 8 years, there was no significant difference in organic carbon additions, which is crazy. What was put into the soil is being used by the microbes. So there were other components, there was more going on there than just that, not moving the needle on the carbon, but it just goes to show that, that can be a good organic matter, organic carbon can be a good indicator, but it's a lot more complicated than just that. And it's hard to move that needle.
Right. And it's always, if we're not employing multiple soil health related practices at the same time, then it's kind of hard to attribute a lot of valuable to just doing one thing at a time and studying it, although that's it's less confounding from a study standpoint, but not exactly what we'd like to duplicate, right, in the real world, because we always want to incorporate more practices than one at a go. Yeah.
All right, any other questions for Linda or comments, discussion?
You kind of hit on this already a little bit, but I'm just wondering if you're just not hitting a critical threshold and that's why you're not seeing that as an indicator of yield or quality.
So the other potentially, but some of these fields have been in, no-till or not no-till, but direct seed, really reduced tillage, cover cropping for a large number of years. I think so these big data sets are really great, but I also am wondering if we've kind of watered down the impact on yield. So we're doing some kind of separation of the data set to see if maybe there is something there. But so far we haven't really seen that. And so that's the other reason of doing this deep dive. We can actually separate out, compare apples to apples. So 2 fields, one that has management practices and the other one that doesn't, keeping the irrigation system, the soil type, everything, the beet variety, everything else the same, and just compare apples to apples. Because again, like this data set is really awesome for these large conclusions and next steps, but it might have watered down kind of the impacts. But also we just may not be seeing seeing that increase in yield or quality. And but we would likely see an increase of resilience in those tougher years with reduced water allocations and things like that potentially. So that'll be part 3.0, is that resiliency component.
Linda, Barry Delkey, can you hear me?
Yes.
I think when you presented this on a field day, you indicated that this was The sugar beet industry was looking at this in terms of perhaps quality and a marketing issue. Is that still part of their focus?
So they're a lot, I think a lot of their interest is, well, twofold. One, as an industry, they're very concerned about the, water use in their industry, especially with the recent droughts and allocations. So they're really interested in that resiliency piece, that comes down. So maybe you don't get an increase in yield every year, but you have a better yield in a dry year or a poor year than someone who didn't. And then part two is, their consumers are really interested in wanting, sustainable practices, but how do you assess those sustainable practices? And then, and this could be an indicator that they could use of, yay or nay, because you want indicators that are sensitive in your growing region, so you don't push out producers that are trying something, but it's just, they're not moving the needle. So they're marketed as not sustainable anymore, even though, they're doing that work.
Yeah, thank you.
Alrighty, any other questions for Linda? Okay, well, thank you so much, Linda. And I think we'll go on to Mr. Pat Purdy, if you want to share your screen.
Alrighty, how does that look? Can you hear me and can you see me?
Yep, looks good.
Okay, well, so just to introduce myself, again, Pat Purdy, we farm and ranch out of the town of Picabo. We have tried to introduce a new tool to our toolkit this last year in 2022 season called sap analysis, which is something that I've heard a lot about, and I've listened to a lot of podcasts about, but we've never used it as a management tool. And so this is really kind of an overview of some of our first experiences with it. I'm not a soil scientist, I'm not a plant scientist, and certainly by no means an expert on sap analysis. This is really our rookie season, and we learned an awful lot in this process. We know a lot more today than we knew when we first started the process, but so you'll see some things we maybe should have seen earlier on in the process had we understood what we were looking at as well as we do now. So so just I'm going to start out with soil testing. Of course, I think a lot of us do soil testing. We tried to rely on that for a long time. We used traditional chemical extraction soil tests for many years. We really didn't see any kind of a correlation in those chemical extraction methods. And so in 2020, we found a lab back in the Midwest that did do the chemical extraction methods, either Olson or Bray or Mylec 3 analysis, but they also added on top of that a Haney test, this what they call a SLAN test, and an aggregate stability test they call a VAS test, just to give a broader picture of what your nutrient availability and your microbial activity and your organic matter content is. But still, that still left us kind of wanting more. What is really going on with the plant, right? Because that's obviously what pays the bills. Soil health is a critical part of this, but we ultimately need to see the impact of it in the plant. What's really happening during the growing season in the plant? And so we'd been paying attention to sap analysis, but we'd never had tried it before. And so we decided to go ahead and jump off the cliff and try doing some sap analysis. And we chose this versus tissue testing. There's some important differences between the two. Tissue testing is really a measure of the total accumulation of the nutrients in the plant tissue up to the time that you took that test. Whereas sap analysis is a much more dynamic measurement of the nutrients that are moving through the vascular system or the circulatory system of the plant, and the phylum and the xylem. The phylum and the xylem. Sorry, hard words to say. So those are essentially the veins in the plant that move nutrients either from the roots up into the main leaf within the main plant structure, or within among the leaves. So anyway, sap analysis, we feel, and I think there's general agreement that sap analysis gives a more accurate measure of what's happening in the plant right now. When I took that sample, what was happening in the plant? SAP analysis also has the advantage that it measures all three forms of nitrogen, the nitrate form, the ammonium form, and then the total nitrogen. So you get to see kind of the breakdown of what your nitrogen looks like in that plant, and that you'll see how important that can be here in a minute. And timely SAP analysis, maybe multiple testings through the season, will actually show you nutrient deficiencies before they become visibly apparent in the plant. So you can rescue a plant before you've caused irreparable damage to it, where you've had a significant loss in yield. You're able to see that coming with timely SAP analysis. So I'm going to, again, given the limited time I have, I'm going to jump right in. This is just cut and pasted off a couple SAP analyses we took on some brown mustard seed. So I've cut off the headers and cut off some of the other information. So on the left here, you can see we took this sample on June 13th of this last season in the brown mustard field. And then the right side is the same field on July 19th. And I just kind of overlaid the two together. And one thing that you need to understand about SAP analysis is when you're taking a SAP sample, the preferred method is to take some old leaf, meaning some of the lower viable old leaf, and then some of the new fully formed new leaves, and you take those in two separate sample bags. So when you submit a sample, you submit a bag of old leaf and a bag of new leaf samples, and so they can see not just what is happening right now, but what did happen in the old leaves versus what is happening in the new leaf samples. And again, things that we understand today that we didn't necessarily understand back in June when we first took these samples. So quite a few things jump out at you when you look at this first sample in June. There are lots of red lights flashing. It's like a control board in a nuclear plant that's having a meltdown. We've got a lot of red lights flashing right now that we need to pay attention to. And I've highlighted several of them over here on the left. But the biggest, brightest red light is down at the bottom in our nitrogen section. So what we've got going on, if you look at the very last line on this slide, you'll see that my nitrogen use efficiency in my new leaf is only 74.6%, and my old leaf nitrogen use conversion efficiency was only 58%. Well, I'm flunking. I've got it. That in terms of, it should be ideally it'd be 100%, and 58% is a good solid F, and 74.5 is a good solid C. So we're not doing very well in our nitrogen use efficiency. If you look up here, we've got quite a bit of nitrogen locked up in the ammonium and the nitrate form. There's something going on in the plant where our nitrogen is locked up in these two unusable forms. And what is going on there is apparent when you look up above, when you understand a little bit more, like I do now, I think a little bit more about plant metabolism. We're missing some critical micronutrients that plant needs to convert that ammonium and nitrate form into useful amino acid forms of nitrogen and the proteins that it can actually use. And so, we've got virtually no molybdenum, for example, critical in that we're low on iron, we're low on copper, we're low on phosphorus, we're a little low on potassium. And so when now we know and understand how to read these, we know what we're looking at now much better, but we have very insufficient nitrogen. We have insufficient nitrogen primarily because the plant metabolism is locked up. It cannot process the nitrogen that's sitting in the plant because it's missing some critical micronutrients here, and we're short on phos as well. So this was no-tilled brown mustard into a pretty coarse sandy soil that doesn't hold water or nutrients that well. It was taken in off of desert ground many years ago, and it's pretty coarse sandy soil. So I'm going to jump to my next slide. So based on this SAP analysis, we came in and we applied. Again, this is a foliar application with our ground rig sprayer, foliar application, not chemigated. We wanted maximum leaf contact without washing the nutrients to the ground. So we used our ground rig. We applied about 14 pounds of nitrogen. We definitely carried a good amount of carbon along with that, but we also applied pretty extensive micronutrient package at that time with some calcium, some zinc, iron, manganese, copper, boron, moly, cobalt, carbon, We also had some sulfur in this mix as well. But so we saw what we were missing. We made that micronutrient application. We were at this time still working with two different labs. This particular sample is from a lab called New Age. We also we pulled another sample. We sent that sample to a company called Nova Labs in the Netherlands. I don't have that sample to show you. I couldn't figure out a way to lay three samples all together. So that sample, we saw some significant improvements in that sample. We saw that we brought our nitrogen levels up into an acceptable range, but we were still short on a number of micronutrients. So again, in the time scale, we came back in on July 8th. We put another small amount of nitrogen, again, with some carbon. We will always put carbon in with our nitrogen applications, some type of fulvic or humic acid or both. We saw we needed still some additional phos, we needed some additional potash, and we also still needed some additional amounts of these micronutrients that I have listed here. So we're now into this crop only about 45 to 48 units of nitrogen. Right, this is a mustard crop that would typically demand about, traditional methods would be probably 100 to 150 pounds of nitrogen on a crop like this. We came in pre-plant with 30 units of nitrogen. We applied this additional 14 pounds here based on our SAP analysis. We applied a small, less than 1 unit of nitrogen in the second. And here's where we ended up on July 19th. This was the final SAP analysis we took. So we can start down here at the bottom. You can see we moved the needle significantly in our nitrogen use efficiency. We're now up into the A, good solid A minus range for nitrogen use efficiency. We've reduced our ammonium and our nitrate levels in our new leaf samples down to not zero, but much lower levels. We increased our total nitrogen in our new leaf and in our old leaf significantly. You still could argue that maybe we're a little bit low on nitrogen. We improved those numbers substantially. Our nitrogen use efficiency really, we're up in good, solid, acceptable range for nitrogen use efficiency. And you can see we moved the needle, pretty dramatically in our boron, in our copper, in our iron, in our manganese, in our moly. We're still probably still a little short in our moly. This was all done with obviously the intention, of trying to get this plant metabolism functioning correctly. We also, some of our other macronutrients, you see we improved our sulfur, although we still, so our sulfur is much improved. It's a little bit of a trick to learn how to read these, because you've got to understand what are your mobile and immobile nutrients, because you read the graphs differently for mobile and immobile nutrients. And I don't really have time, unfortunately, today to go into all of that on how to interpret these SAP samples. But the net result was we produced a mustard crop with good above average yields with less than 50 units of nitrogen, but with putting a lot of emphasis on micronutrients, and a small amount of P and K in the mixture. So for a very reasonable investment, I apologize, I don't have the total number of what we spent on total nutrients, but for half or a third of a typical nitrogen application, we were able to meet that plant's nitrogen needs by focusing on getting that metabolism working in an efficient manner versus just plowing nitrogen on it, that which we would have historically done. We would just have come and we'd have been pouring our traditional macronutrients on with really not a whole lot of regard for what's going on here in these micronutrients, overloading the plant's metabolism with too much nitrogen, and not understanding that what we really needed to do was get that plant's metabolism working again, so it was converting that nitrogen and being able to utilize it. So I think we had very real successful results with this. We're very happy with what we learned. We certainly understand a lot more now than we did when we first started with this, but we're still just 1 year through our rookie season. So we've got a lot to learn, and it's definitely a process still. So that is kind of the end of it for me. So if anybody has any questions, I'd be happy to answer them.
Yeah, I've got a question. Can you hear me?
Yes, I can.
So Tom Wood here, over here to Newdale. In
Okay.
light of the data that you have here now, will you try to amend soil with the knowledge that you have now? If you're traditionally always short on these micronutrients, are you looking to do soil amendments, or will you continue with the foliar program?
Well, I'm having that exact conversation with my crop consultant, and we'll do both. We are actually retrofitting our drill. We have a John Deere 1890 no-till air seeder. We're going to be doing some liquid in-row application so that we could place some of the appropriate micronutrients in the seed row in the coming seasons. Some of these micronutrients will just tie up and bind if we put them in a soil applied. I apologize, I can't tell you exactly which those are. I just know that some micronutrients are not appropriate to be soil applied, or they're not very efficient that way. So we will do a mixture of both. We'll do a little better job up front so that we don't have some of these major nutrient deficiencies right out of the gate, but we will also probably be in there earlier with foliar applications. I'm a big believer. We own our own ground rig. I'm a big believer in foliar applications. I don't have a bit of problem going over that field 2 times, maybe even 3 times in a season with some foliar applications, and I certainly intend on continuing to do that as needed to try and minimize my total fertilizer inputs and maximize my yields. Putting a ground rig across the field, if you already own it, is just not that expensive.
Yeah, Pat, Barry Delkey.
Yes.
You commented on putting carbon in with your micros. I've been looking into things like that. I've not done it yet, either something dry into the seed box, or I run into a foliar the other day, which is 5% humic and fulvic acids derived from leonardate and 2% root exudates. Is that comparable to what you've been using?
Well, I would have to defer to Jared Cook. I don't know if he's on the call or not. He got waylaid a little bit earlier, but I know we use fulvic and humic pretty extensively in whenever we're applying nitrogen. We're always trying to carry carbon and some sulfur and some moly along with it to help improve that nitrogen uptake efficiency. I can't tell you specifically the forms that we use.
Yeah, this product's out of Hefty Seeds here in Buell.
Okay.
And they have another one in a talc form that goes into the seed box.
Okay. Yeah, I'm not
You
familiar
have
with that.
experience with that?
I'm trying to rely primarily on liquid.
Liquid.
Yeah, we're trying to do as much as possible with liquid. My drill does have a dry in-row delivery system on it, but I'm gonna probably not use that this year and use a liquid in-row delivery instead.
Okay, thank you.
Pat, and then we have a question in the chat from Cooper Brossi. Are there any domestic labs that you know of that do sap analysis?
Yeah, New Age. These 2 samples you're looking at right here are from New Age labs. They are U.S. based. There's at least one other lab called Apical Lab, and I believe they're in Oregon or Washington. New Age is in the Midwest. Anyway, I've been very happy with what New Age has done. They get a lot quicker turnaround time. The challenge with Nova is getting your samples to the Netherlands and getting, so there's a good solid week plus delay in getting data back from Nova.
I had a question, Pat. What time of, I imagine you just did this one field. What was the time commitment like to collect all of these, the leaf samples, and then analyze and look at all of this data to make your decisions?
No, we ran, I don't know, we probably pulled 30 or 40 samples throughout the season. So my nephew Nicholas, and I would be out there with them helping if I was able. You take two or three guys out, because you got to go out in the morning between 9 and 10 o'clock in the morning. You've got to fill up, a couple quart-sized bags, 1 old leaf, 1 new leaf. Yeah, it's not the most fun thing you'll ever do in your life, but you just get some young people. They don't mind being down on their knees, crawling around. it's, you know, alfalfa is pretty easy to do. You know, a more mature barley is pretty easy to do. The really young barley is a little bit more difficult, but you can also just take a composite sample. Just take basically the whole, or just old and new leaf all in one bag, and you just tell the company that it's a composite sample. Because if the plant is really young, it's very difficult to get a good old and new leaf sample. But they were able to pull, you know, a team of 3 guys could go out in an hour and they could pull 3 fields, I think, pretty realistically. I don't know if Nicholas wants to comment on that, but I think that was pretty realistic.
Yeah, that was our experience, Pat. We could easily do 3 fields. Alfalfa, we could get up to 4. And then late stage barley, we could easily get 4 or 5 fields because it just doesn't take, you have to get to about 80 grams per bag. So it just, you know, you go out there with individual bags and you just pull as many leaves as you can and then weigh it and move on as quickly as you can to the next field, and try to do fields centrally located to where you are. Pick your samples geographically close.
So we used, again, we were trying to stay within about an hour sample time between 9 and 10 a.m. in the morning, just to be consistent with that. And you know, we would pull barley fields from varying parts of our farm and different soil types. We didn't necessarily pull the same field all the time, but we would pull representative fields, and then we'd go make applications on all the fields that were represented by that field in terms of soil type and growth stage. And you know, we had the you know, we had some other challenges, but we had by far the best quality of barley that we've ever produced this last season. Plumps and protein levels were the best we've ever seen. So very happy with this analysis, and I think it's probably the best tool that we've found so far to really know exactly what's going on. I just don't think you can duplicate this with soil analysis. I don't think that soil testing gives you this kind of right now data.
I agree. This is great. Thank you.
Pat, we have a question about taking samples when it's cold, basically during morning frost. So I'll answer this. We avoided going out there too early. So if there's physically frost on the field, we didn't pick that portion of the field. I felt that would actually skew the data. So we were trying to stay in front of the pivots or in front of the wheel lines where there wasn't frost, or not take a sample on frosty days.
Yeah, we just wait later in the day in a day like that, where the frost has come off. Yeah.
There's a lot of data, Pat. It's really, really impressive. I wonder after the foliar application if it was evident, if you had a response from the plants that seemed evident visibly.
Oh yeah, every sample that we took when we did a foliar application, we saw a response. They like you to wait 5 to 7 days before you take another sample. But we absolutely saw a response, I would say 100% of the time to what we did, which is, yeah. That's gratifying, right? You know, to know that you actually move the needle and that you're actually doing the right thing, that you're not out there, you know, just dumping more nitrogen on when your plant metabolism can't process it anyway. So
yeah, it's impressive that the trace elements were able to boost your nitrogen use efficiency so much. That's a really good, really good presentation. Thank you.
Any other questions for Pat? All right, well, thank you so much, Pat. And I think we'll move on to Nick Waters.
Good morning, everybody. All right, Courtney, can you see that screen?
Yes, you're looking good.
All right. Well, good morning, everybody. I'm Nicholas Waters with NRCS out of the Twin Falls field office. This will just be a quick presentation manure and compost, if nothing else, I just wanted to bring your attention that NRCS has some conservation practices that could help offset some costs if you're interested in applying manure or compost as a soil carbon amendment. And then if nothing else, this isn't an NRCS recommendation, just a personal recommendation. Wendell Berry's book, The Unsettling of America. I think I'd be remiss in a soil health forum without including Wendell Berry. I just really like him. So at one time, plants and animals were raised together on the same farms, which therefore neither produced unmanageable surpluses of manure to be wasted and to pollute the water supply, nor depended on such quantities of commercial fertilizer. The genius of American farm experts. So he often chides, the governmental system of which I'm a part. So just take it tongue in cheek, is very well demonstrated here. They can take a nature-based solution and divide it neatly into two problems. So the next slide here, if I can get it. Let's see. There we go. I just wanted to bring your attention to what the University of Idaho is doing in terms of, this problem that we kind of have with manure concentration in the Magic Valley in particular. So this Idaho Sustainable Agriculture Initiative for Dairy, if you guys aren't aware, I would just recommend you, Linda Schott, I think is a part of this, and it sounds like they're going to be doing some great work. I think their idea is trying to take this problem of lots of manure, too much in the Magic Valley, and trying to, figure out how to value add something on top of the manure. They're talking about, I think, combining biochar with liquid manure as a way for wastewater treatment in some roundabout way, bioplastics, all kinds of things that are trying to address the fact that the economics currently aren't penciling to, take the manure from where it's produced and distribute it efficiently. How can we, value add and make it pencil? So I just wanted to bring your attention there. Some folks trying to work on the problem. As far as NRCS goes, if you were trying to tackle the problem more from just the inherent value of the manure or compost, we have some cost sharing practices that might be applicable. One of which is this soil carbon amendment. And, cost share rates on this range from $80 an acre if you're looking at application of 1 to 3 tons of compost per acre, up to $232 per acre if you were applying 3+ tons of compost to the acre. One thing I'll say on that 808 practice, it's going to require STA certified lab testing, and I've got a slide down the road that'll kind of elaborate on that. If you had a lot of manure and you were thinking about composting, we also have a practice that gets into a little bit larger scale. So if you were looking at developing a composting facility, we've got cost share rates to the tune of $28,000, $35,000, depending on what you're doing for your base. So if you're looking at ramping up compost production, NRCS has some cost share there. And then this last one, it's one of NRCS, it's kind of esoteric, a SEMA, Conservation Evaluation and Monitoring Activity. So those are trying to look at the effects of a conservation practice that gets put on the ground. And from what I can tell, I think this SEMA for soil and source testing could potentially be used to offset testing costs on that compost if you were going to do something like a soil carbon amendment using compost. As far as this STA certification, it's coming from the U.S. Composting Council Seal of Testing Assurance. And there, the Composting Council has a list of STA certified labs. And there's a link there. The only one in the Northwest that we could find from their list is Soil Test Farm Consultants out of Moses Lake, Washington. And I think part of this STA requirement, it's using this TMEC protocol, which is test methods for the examination of compost and composting. Those samples run $80, and I'm sorry that this slide kind of got skewed, but $80 a sample. And two of the requirements for NRCS on this is carbon to nitrogen ratio and moisture. And those are included in that test. Something that I think about, NRCS often cites, I do, a 1% increase in soil organic matter equates to roughly 1,000 pound increase in stable or slow release nitrogen per acre. Additionally, that 1% increase in soil organic matter can help the soil hold up to 20,000 gallons more water per acre. And I guess what I'm wondering, these kind of have the flavor of being anecdotal. I think they're fascinating and they're important statistics illustrating the centrality of soil organic matter in a healthy, efficient system. But I'm just wondering if they're perhaps a bit too nebulous for the purposes of instilling like a widespread confidence to begin using the nutrients in this compost or manure to substantially offset synthetic fertilizer use. So in other words, in the Magic Valley and beyond, are we just, trying to spread the manure around the problem and simultaneously following fertilizer recommendations in the absence of manure's contributions, and as a result, loading soils and not, minimizing those input costs? So I just see there's a need, and they may be out there. I know the American Farmland Trust is starting to get into some of these economic case studies, but I think those could be potentially really valuable if in fact they can get to the nitty gritty and the specifics on cost benefits. So I just wanted to put that out there. If folks know of good economic case studies out there around manure, compost, or anything related to soil health. And I just wanted to mention this idea of externalities in the context of these case studies. An externality is a cost or benefit caused by a producer that is not financially incurred or received by that producer. So with something like manure, there's this externality. We're looking at eutrophication of our water bodies, nitrates in groundwater, that kind of a thing that may not be always incorporated into a cost benefit analysis. If we're looking at, it's just not economically efficient to move this manure around. I think it's important to think about externalities. And with that, I think I'm done.
Thanks, Nick. You ask about the use of manure and kind of a analysis of its efficacy. It reminds me of a presentation I saw at the Idaho Potato Growers Conference. Mike Thornton from the University of Idaho was presenting on this, where they were growing potatoes there's a 2-crop rotation versus a 3-crop rotation, and adding composted manure and not adding composted manure, and yield was shown to be better for the treatments where they had added the composted manure and had the three crop rotation. So I think that lends credence both to our conservation crop rotation and soil carbon amendment practices. And I do not have that additional information on his study. I know Linda and Courtney saw that presentation too. Maybe they could comment or have additional information on what they were doing there.
Yeah, I don't know when they're planning on releasing results. I think that they just got another 5 years of funding to continue that project. Linda, maybe you should verify that. But so hopefully I would imagine they'd be putting out some information on that soon.
Yeah, they're gonna, they should already they have those results. I just don't think Mike presented on them because there wasn't enough time to get into all the nitty-gritty details. But yeah, that 5-year project, the initial one is coming to an end. I think this year is the last year, but then they're extending it for 5 more years.
I wonder if he would be available to talk a little bit about that.
Courtney asked.
I asked him, yeah, he's busy. He was busy today and they're planting potatoes when our next 5 for 5 is in April. So unfortunately, we won't be hearing about that on a 5 for 5. Maybe we can make that happen in some other.
Maybe you could reach out to Jeff Miller from Miller Consulting. He is the one who, like, it was his research farm that was used for this project.
Cool. Okay. I'll write that down. Yeah, that would be nice to hear more about that.
You could always follow up with Mike and ask if Jeff could present on that data.
Thanks, Linda.
I have a question on the cost sharing. I wasn't clear exactly what they're willing to cover and pay on that. And I bring this up because I've got a compost truck that's supposed to be here in about an hour. There's a gentleman down in the Magic Valley that I've become affiliated or associated, got to know the last couple of years through my paying job, that there's a few extra steps he goes through. He makes kind of a high-end compost. We worked out a deal this year with the economic value of the straw up here, that we worked this out, that for every ton of straw that he takes off of my farm, they will deliver and spread 1.5 tons of this supercharged compost. I guess I would like to do more of the farm. Like, this limits me to just a few fields. It doesn't match. I don't have enough. We're going to do a 2-ton spread with this supercharged. On the cost sharing portion of this, are you saying that somebody in the office is willing to write a check to help facilitate a deal like this, to offset the freight, to move it this far? Or what all does the cost sharing cover?
Yeah, that's a great question. Maybe most broadly, if you're interacting with NRCS, you're probably interfacing through one of our 2 main conservation programs, either EQIP or CSP. EQIP probably would be more amenable. Those can be, short-term 1-year contracts. In essence, what you're doing is you're agreeing to employ a conservation practice. And in this case, it could be the soil carbon amendment utilizing compost. And our conservation practices are designed to, treat a resource concern. And so the soil carbon amendment is targeted to increase soil carbon and improve the physical, chemical, and biological properties of the soil. So if in your instance, you're wanting to use compost to do just that, increase soil carbon, improve the structure of the soil, you could be eligible for an NRCS cost share contract that would potentially pay those numbers that I cited on a per acre basis. So you agree to, apply compost that's been certified by one of these STA labs in terms of the CN ratio and the moisture content. You do that, NRCS certifies it. We come out and make sure that you've met the standard and spec of that 808, and then you'd be eligible for that, per acre cost share rate.
Okay.
I don't know. Hopefully that addresses your question somewhat. I'm sorry.
Yes, no, thank you.
Nick's Barry, how long has that been in place?
Oh, Sean might be a good one. That 808, I think it's relatively new. I think maybe within the last couple of years.
Yeah,
Yes.
never heard of it before.
Yeah, it is relatively new. And it's was adopted as an interim practice, meaning that they don't have all of the kinks ironed out with it. So when we say we've got an interim practice, it means it's something we're kind of trying out, and several states have adopted it across the West. But yeah, soil carbon amendment with the focus on improving your soil carbon, physical and biological properties. It's if you are interested in it, please reach out to someone like Nick, a soil conservationist in one of the USDA service centers, and they can talk you through what that would look like to get involved with a program that would cost share on that with you. I think it's
I've
a great.
never bought any. I just spread my own that we make. But, you know, I live in the middle of a dairy milk shed, and these trucks are running constantly. And two things, I'm sure there's neighbors that could benefit from this, but I'm wondering what kind of kickback you're getting from the commercial fertilizer industry. Those are pretty good numbers, pretty healthy numbers to be paid on a per acre basis,
Yes, sir.
especially in terms of the value of crops.
Yeah, and I think in
As
this
a second
area,
thought, Nick, you know, this is more for you than anybody else. There's an interesting little book by Gene Lodson, published in 2010. It's called Managing Manure to Save Mankind. And it addresses some of these issues, as well as Newman Turner's books that were published prior to the industrial fertilizers and how they managed it in years past, when there was a better balance to begin with. But interesting read, Nick.
Thanks, Barry.
Yeah, you bet. Thank you.
oh, I've got to say, Nick, one last comment on those, the numbers, the 20,000 gallons of water per acre with an additional % of organic matter. That upper limit is very theoretical. More realistically, the National Soil Survey Center at Lincoln, Nebraska, their research soil scientists put out a paper, and more realistic values for that would be on the order of like 3,000 gallons per acre. So, but that number has been repeated and repeated and repeated, that it's kind of hard to stop it. It just keeps on showing up like a bad penny. But yeah, so at any rate, that's all I had. Thank you.
This is Barry again. If I can make one comment, please, and it's regard to soil test. Sean, you're aware of this, and Linda and Courtney, in fields that I've cover cropped and manured, it's pushed my base saturation rate for calcium below the normal range. And apparently the issue there is the very, very high potassiums, which also come from manure. And so that's one of the things I'm trying to address now, actually through the use of gypsum, of all things, in an alkaline soil. But that can certainly be the consequences when you get into 3+ ton, or maybe even less than that, because I see it in two particular fields, both of which have very high organic matters, where I don't see it in any other fields on my place. So food for thought.
Thanks, Barry. Yeah, it's definitely to be
Have you
used
looked at your
judiciously.
magnesium there also? Because magnesium and calcium can interact, bind.
You know, we're talking about very high potash, 1,000 or even higher, as high as 1,600. High phosphate levels. Magnesium, I'd have to go back and look, but exclusively in two fields that are 5 and 6 organic matter that in large part have either been cover cropped and harvested in place for the last several years. One is actually going to a new seeding, but those were the soil recommendations. If I'm not sure who you are, but if you want a copy of the soil test, I can do that. And it's been a question we've been chasing around in circles, but what I'm told is the potash is pushing the calcium off the clay particles. It's a silty clay loam. So we're going to see what happens, because it's going to be a mixed seeding of alfalfa, sainfoin, and 3 different cool season grasses. Harvested as hay, grazed in the fall.
Yeah, I'd like to hear about that as it progresses, Barry.
I'll keep you in the loop, Sean.
Okay, thank you.
All right, any other comments or questions for Nicholas? Perfect. Okay, well, thanks for that presentation, Nick, and the info. I think we'll move on. Last but not least is David Anderson.
Thanks, Courtney. Hey, as a segue, Nick had made a nod to AFT about looking at manure compost. And so just wanted to let everybody know that it's our intention we're going to be submitting a SIG application this year to start scoping the concept of a compost manure marketplace. And so it's definitely going to be a phased approach. I think our first phase in this first application is really just scoping and gathering what we know. You know, like we just talked about, we've got a lot of potential data already we can use, but then looking at, you know, what are our data gaps? What do we not know? And with the ultimate goal of looking at the actual economics and scale of creating compost manure marketplace, whether they be, you know, at the micro level or at the regional level. So more to come on that. I think the next step that we're going to have there is just get our like-minded folks in a virtual room together and talk about what we need to scope for that application. So of course, Nick and Linda, you'll be part of that invitation. All right, so I'm just going to share my screen here real quick. All right, are you seeing that, Courtney, full scale?
No, I'm
No.
not.
Okay, I've got myself on the wrong share. Hang on a second here. I never quite get that right.
Okay, there we go.
And is that display mode?
Yep, that's perfect.
There we go. All right, thanks for your patience, everybody. So rounding out our presentations here today, I want to tell everybody a little about the Idaho Farmer Learning Network, which is a project that is being hosted by the Idaho Center for Sustainable Agriculture. Want to make a nod to our partner, Anheuser-Busch InBev, who have been generous in supporting us in standing up the Farmer Learning Network. A little bit about ICSA. I know a lot of folks on the call here have heard of us or even directly participating with us. We are a nonprofit organization, and that we're connecting regional ag producers with the knowledge to address economic viability and resilience in a changing environment. And so really what it is that think of us as a knowledge hub, and we're a working board of volunteers that represent these organizations that you see here on the slide. So as part of that working board, we are a think tank. We are always comparing what each of us is doing in our own viewshed in the greater soil health and regenerative ag space here in Idaho, and then looking at opportunities to connect systems and connect resources and plus up soil health learning here in Idaho. So the Farmer Learning Network is simply, it's a peer-to-peer learning network. It's recognizing that farmers learn best from other farmers. And so how do we get them the results and practice-driven data in order to spread through that learning network? And in particular, we're really focused on Idaho-based case studies. I think that we're all very familiar with, there's a lot of information coming from other places outside of the state. So I think in order for us to really get a higher capture rate, focusing on Idaho-based case studies that are looking at both row crops, rotation within those crops, and eventually even extending that to range land and getting that real data out to our local folks is key. So how does it work? Really what we're doing there is that we're canvassing our soil health partnership, which is all of you on this call, to identify growers that are practicing soil health methods. And then looking at that list and deciding which of those are candidates for soil health economic case studies. This is a partnership that we're going to be doing with American Farmland Trust, with our national team. They have which referred to as a retrospective soil health economic calculator toolkit. We're going to be applying that to 2 different operations here in Idaho this year. And the results of those case studies are a very slim 2-pager, easy read. And then continue to collaborate with the soil health partners to add additional learning materials that are adjunct to those case studies so that we can create a cohesive learning package. And then ultimately offering in-field learning events with these case studies. And so essentially reviving the Granges and getting the neighbors around these farmers and so that they can see what's going on locally there. So what's next for the Farmer Learning Network here in 2023? Like I said, we've got at least 2, maybe even 3 case studies planned for this year. Our goal is to present those this fall after the crops are in and people have settled down a little bit. We'd like to have a learning event, probably somewhere central in the state around Magic Valley. We are also in the process of building a mobile-friendly and web-based platform to host both the case studies and other added information, links to our soil health partners and the work that they're doing. I'm emphasizing mobile-friendly because so many of our farmers are really, that's the fastest way that they can access information, get home after dinner, not so interested in getting online. We'll also be participating with the Soil and Water Conservation District local working groups. Many of these the districts have either an annual or a semi-annual learning event, and so we will be getting on the agenda for those presentations. And then we're also publishing a bi-monthly newsletter, and so if you sign up with us, you'll be able to receive that. And once again, we're just looking for fresh knowledge, new information, anything about those case studies that we push out. I think that's it for right now. Kept it pretty short there, Courtney. Is there any questions or feedback from the crew?
Yeah, Barry Delkey again. I see you're planning a meeting in the fall of this year in Magic Valley.
Yes.
Yeah, good. How are you going to advertise that?
We have the key. The network is the keyword, and so everybody that you see here is on Courtney's mailing list. I mentioned that we have a working board, and we're very happy to have the U of I Extension represented on our board with Courtney as a board member. So we have a number of mailing networks, either through the Nature Conservancy, NRCS, U of I Extension, and AFT. So if you got an email to this event, then you will definitely be getting an email about the workshop this fall.
Yeah, fair enough. So Courtney's a point of contact.
Yes.
Good. Yeah, she's reliable. Good. Thank you. Bye-bye.
Yeah. Looks like I knocked them dead, Courtney. They're all yours.
You did so great. Thank you, David. All right. Is there any, we can do more questions for David, or if there's any other comments. Oh, we have a question in the chat. Does AFT have chapters in other states?
Yes. So we are organized both nationally. We have our national programs. A lot of those are in partnership with NRCS. And so we have our national programming. And then in our target states like Idaho, we then have state level programming. If you want to learn more about us, let's see. Actually, Courtney, can you put it in the chat? I'm not very fast at this. It is farmland.org. O-R-G is our website. And at the top left corner of our website, you'll see a button that says Farmland Information Center. In partnership with NRCS, we are the largest single database of farmland information in the country. So I invite you to get in there, query the heck out of it, and have fun.
It was just farmland.org, right?
Correct. Thank you for that.
If you can click on that.
I can't type and talk at the same time.
Just a note too, Courtney, I put a link in the chat for that paper that I had talked about. Taryn asked about that. So yeah, if you want to read up on how they came to the conclusion, or what they had to say about that overestimating the amount of additional water associated with an additional 1% of organic matter in the soil. That's all there. So.
So Courtney, I'm late for another call. I'm going to bounce off.
Awesome. Okay, well, thank you so much, David.
Thanks, Courtney. We'll see y'all next month.
See you. All right, well, yeah, and if we don't have any other questions or comments.
Wait, I've got one last one.
Oh, go
Yeah,
ahead.
me too.
Yep. Yeah. Well, that's funny, Barry, because I was going to direct this comment to you. I don't know if this issue with the potassium, I think you may have mentioned it to me. I don't recall seeing those test results, and I was thinking that it has to be an awful lot of potassium to be doing what you're saying. And if you wanted to share those with me, I'd be happy to talk to you about them. Not that I consider myself a pro at soil chemistry, but I think it'd certainly be interesting to look at, and I'm more than happy to talk with you about it.
Be glad to do that. Courtney's seen it and Linda's seen it, and I mentioned it to you, but they were field trips and you were busy.
Okay.
So, but I'll see that you get them.
Awesome.
And thank you.
You bet.
I have one question for Tom about his trade straw for compost. I assume that was done on the value nutrient basis, or how did he come to those numbers?
This has been a long ongoing conversation. If you're familiar with the Midwest Biosystems theory of producing compost, humus protein that they produce with their techniques, that's it. Tony Regier is the guy that
I am not.
So it's anyway, it's a little different composting technique. There's a little more involved in this than just dehydrating manure. So anyway, Tony and I have worked together at some conferences and speaking engagements and whatnot, and this has just kind of been an ongoing evolution. Basically, we just sat down here this summer finally and said that this is what the value is at my place for the straw. He gave me the numeric value for what he gets for compost in the Magic Valley, what his spread rates were. We figured out the trucking rates, try to just kind of make this work out for everybody for, a long-term. We want this to become a long-term deal between us. I've got another neighbor here that got involved as well. So it would just we sat down and put everybody's numbers together, and for the freight distance from where I'm at to get from Buell to Newdale, that's just kind of where the numbers landed, that a ton of straw was worth about 1.5 tons supercharged compost delivered and spread on my farm. So.
What's your last name, Tom?
Wood.
Oh, and you're in Buell?
No, I'm in Newdale. Tony's down in the Wendell Buell area. So
I see. Okay. Thank you much.
So Nicholas Waters, is that the person that and Tom too, is this person that's making this compost, Nick Waters? Are you familiar with their operation?
No. Yeah. And Tom, would you be willing to tell me that gentleman's name again?
Oh yeah. The gentleman I'm dealing with, his name's Tony Regier, Regere.
Thank you.
It sounds like that might be a good, a good product. So thank you. I appreciate you sharing that with us, Tom. That's super cool.
Yeah, great idea.
Like I say, if you're interested more about Midwest Biosystems, they're based out of Tampico, Illinois. He does workshop stuff. It gets called compost, but because of the process they go through. But if you're making the really high-end stuff, the carbon or the humus protein, generally there's not even any manure involved in that. It's a whole controlled formulation. Your carbon your carbon to nitrogen ratio, you're shooting for a 30-to-1 carbon to nitrogen ratio. You've got to test your carbon ahead of time, test your nitrogen source ahead of time. It's a very difficult product to make. But basically what Tony's doing is he's going through all of the steps that are involved in making humus protein. He's just making this out of manure rather than controlling the carbon and nitrogen inputs in the beginning.
Is this Mike Regier's brother?
I'm sorry, say that again.
Is that Mike Regier's brother?
Could be. I don't know. I know he's got a brother because I actually knew these guys back in my trucking days 20 years ago, but I don't know who his.
Yeah, Mike farms here, and his son Ty has a vegetable greenhouse business. So they would use a lot of that, I would think.
Oh,
Thank
probably.
you. Very interesting, Tom.
Sounds like this might be a good topic for the next 5 for 5, Tom.
Well, I'll get somebody lined up to tell you all about it then, Brad.
Hey, Tom, I'm the new extension educator in Madison County. I'd love to chat with you more about that if you want to reach out.
Yeah, I'll be in your office this afternoon then.
Oh, that's fine with me.
And as for your question, Cooper, the recording of this I'll be posting it on our YouTube page, which the link is right here. And it'll probably be up within a week or so.
So, and we've tried to put in comments on those so that you can see what topic is being covered at what time and forward to that part of the video, you know, the part you're interested without having to wade through it and figure it out on your own. So.
Right.
It's a good lineup today, Courtney. Thank you for steering this and playing MC today and putting it together.
Of course. Yeah, this was fun. Thank you everybody for coming. Yeah, recording will be up in a week, and the next one, our last 5 for 5, will be on April 5th. So yeah, if anybody else wants to talk, Tom, yeah, in our last 5 for 5, feel free to contact me. And yeah, I really appreciate everybody coming, and it's nice to get to chat. And yeah, I think we can close it if anybody, if everybody's good to go.
Okay. All right. Thanks, everyone.
Thank you.